familiar, right? Our curly bracket. We're defining a function that has two different pieces to it. We're going to see something when x is less than 2, which is to the left of 2, and something else when x is bigger than 2. And I think the easiest way to figure out what this looks like is really by plugging in values for x. All right, so what did I do? In my blue table, I'm going to be graphing x squared because these are x values that are less than or equal to 2. So I'm going to plug them into x and find the y values. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And at that last point when x equals 2, I'm just going to put a closed dot there to remind myself that on the graph that's going to be a closed circle. And before I make the graph, I'll also just fill in my table for the other function, 2x plus 2. Now, even though it says we're going to graph this when x is greater than 2, I still want to see what's happening at x equals 2. So when I plug in 2 for x, 2 times 2 is 4 plus 2 is 6. That's going to be an open circle. When I plug in 3 for x, we're going to get 6 plus 2, which is 8. And then I'm going to get 10. And then I'm going to get 12. Because the slope of the line is going to make it such that the y values increase by 2. So with this information here and my knowledge of what x squared and 2x plus 2 look like, we should be able to come up with a pretty decent looking graph. So we've got the point, if I go kind of backwards here, I'll start at 2, 4, and then work my way backwards here. We said that that's a closed circle. We've got 1, 1, 0, 0, -1, -1. I know what this parabola looks like. I mean, we've graphed the function x squared countless times this year. It's going to look something like that when x is less than or equal to 2. So I definitely have to stop when I get to 2, but I do want to continue all the way to the left there and show that entire side of the parabola. All right, then we got 2x plus 2 to graph. So we've got this line. So that's going to be at 2, 6. You're going to see an open circle. And then we've got 3, 8, and 4, 10. And, I won't plot 5, 12. We can imagine where it would be. That line's going to continue on in this fashion forever and ever. So I hope that this process of graphing piecewise is something that looks and sounds familiar to you. What we're going to do is we're now going to extend this, that since we have the graph in front of us, we can evaluate the following limits. One note about these limits is that there's a different notation. And there's a little negative sign that almost looks like it's the exponent for this too. I don't know if you guys can see that clearly. I really hope you can. But I'll tell you that little negative sign right there means we're approaching 2 from the left-hand side of the graph. This is the left-hand side of the graph. This is the right-hand side of the graph. So the notation for approaching a value of x from the right-hand side is when you see that little plus sign in the what looks like an exponent. So it's the limit as x approaches 2 from the right-hand side of 2. And then this is the notation that we saw yesterday where it's just the limit as x approaches 2. So we can do what are called one-sided limits. These are one-sided limits from the left-hand side or from the right-hand side. And I'll talk about how each of those results would affect what the limit as x approaches 2 in general is. Let's go from the left-hand side. So start on the left-hand side. And as x gets close to our value of 2, I want to know what's the y value for my function. Because that's what it would be if I was doing this algebraically, right? So start on the left side of the graph. And when you're approaching from the left, you're actually traveling to the right. So I know that sounds a little bit weird, but from the left-hand side, you're following the parabola. You're getting closer and closer and closer to x equals 2. What's f of x approaching? F of x is approaching 4, which we know from the table anyway. So the limit as x approaches 2 from the left is 4. Well, what about from the right-hand side? On the right-hand side, I would actually start up on my red line here. And approaching x equals 2 from the right-hand side, I'm getting closer and closer and closer and closer and closer to an f of x value of 6. Even though there's not a filled-in circle there, remember, you don't have to have a function value for the limit to exist. So it's the concept of what am I approaching? What am I getting close to? Well, as x gets close to 2 from the right, I'm getting closer to a y value of 6, which means that the limit as x goes to 2 for the function f of x, the moment you've all been waiting for, does not exist. Now, I say it's the moment you've all been waiting for. It's only if you've seen that classic line in the movie Mean Girls. Okay. So the limit does not exist, and we just write d and e there. So in order for the limit to exist, as we approach a value from the left and right-hand side, it has to be getting closer and closer to the same value. In other words, if the left and right-hand limits don't match, then the limit does not exist in general. Hopefully that concept makes sense. Okay. Let's go ahead and take a look at some other examples here. All right. On the back, we've got another set of functions here. Now, this is also a piecewise function. It looks a little bit different because I feel like we're used to kind of seeing inequalities here for this part. But this one just says graph this whole thing as long as x does not equal 2, which means for any other x value, we're graphing this. But when x does equal 2, I want to graph a y value of 1. So actually, I'm going to do this last part first because it's only a single point. This really represents the point 2, 1. At x equals 2, the y value is 1. Otherwise, what am I graphing? I'm graphing 2x minus 2. So, I mean, what do I know about that line? I know that it has a y-intercept at -2. And if I use the slope of rise 2, run 1, and then rise 2, run 1, at x equals 2, the y value of the line would be +2, right? You can plug that in real quick. When I get to x equals 2, the y value should be +2. That's going to be something like this. I don't want to include that value for this blue line here, so just make sure that you account for that. So you're going to see the entire line, 2x minus 2, except when x equals 2, we're going to graph a y value of 1. So that's what that piecewise function looks like. A little bit weird looking, but there it is. All right, let's talk about what's the limit as x approaches 2 from the left first. Okay, so as I start on the left-hand side of the page, from the left, as x gets closer and closer and closer and closer and closer to 2, the y values are getting closer and closer and closer and closer to, not the red dot, but they're getting closer to 2. And in fact, when I start on the right-hand side of the graph, as x gets closer and closer and closer to 2, y is also getting closer and closer and closer to 2. Therefore, the limit as x approaches 2 is 2. So the limit as x approaches 2 for this function is existing here. It's going to wind up being 2. Even though if I said what's f of 2? F of 2 is 1. So these two things don't have to match, and they can both still exist. The function value and the limit aren't the same in this case. What does that tell me overall about this function? It tells me that this function is not continuous at x equals 2. So that's the mathematical definition of being continuous. The limit has to exist, the function value has to exist, but the last part of that continuous idea is that these two things have to be the same. And if they're not the same, then all that means is that this graph is discontinuous at x equals 2. Okay? What I want you to do is go ahead and see if you can graph number 3. We'll go over the limit part together, but see if you can make a table of values or if you can just visualize what it looks like. Hit pause quick, graph it. I'm going to show you what the graph looks like here. Okay, so it's basically a piecewise made up of two things. We got a line, x plus 4, when x is less than or equal to 0. So here's that line. I didn't have to make a table to figure out what it looks like, but I wouldn't fault you for trying to make one, right? X squared, we saw that one earlier. This one we're looking at when x is greater than 0. So notice how we've got an open circle there, closed up here. Here are the limits we're going to evaluate. What's the limit as x approaches 0 from the left? So from the left, here's the left side of the graph. You're going to head up this line. And as x approaches 0 from the left, we're getting closer and closer and closer and closer to 4. And if I start on the right-hand side of the graph, I'm going to hop on the parabola up here. As we approach 0 from the right side, it's getting closer and closer and closer and closer and closer to 0, which means altogether, the limit as x goes to 0 does not exist. Okay, these two things, like we said, have to match identically if we're going to have the limit exist at this value 0. It exists at every other x value. Okay, if I say what's the limit as x goes to, I don't know, if as x goes to +2, as x goes to +2, the limit is 4. Because as x approaches 2 from the left and as x approaches 2 from the right, we're getting closer to that same y value. It just so happens in piecewise functions, because there's usually a jump, not always, but usually, because of that jump nature there, sometimes we'll get some limits that don't exist. Okay, speaking of jumps and graphs, go ahead and take a look at the next page. I'll walk through these examples with you, these two, just to make sure we have a good grasp on what's going on with the graphs here. And then there's kind of a mega graph on the back that'll have you try. All right, so in this one, we're going to take a look at this kind of very random looking piecewise graph. We're going to see if we can answer these questions. Okay, so the first one says, what's the limit as x approaches 1? It's not a sided limit, so it's not just from the left-hand side or from the right-hand side. It's just what is the limit as x approaches 1. So to answer that, even though it's not a left or right-hand side limit, you have to check to see if those two things match. So as I approach 1 from the left, I'm headed towards 0. As I approach 1 from the right, I'm headed towards positive 1. Since those two things clearly don't match, the limit as x goes to 1 does not exist. Okay. The left and right hand limits exist, but the limit as x approaches 1 in general does not exist. Okay, does it exist as x approaches 3? Well, as I approach 3 from the left, I'm getting closer to 2. As I approach 3 from the right, I'm getting closer to 2. Yeah, those two things meet up. So since the left and right hand limits match, the limit as x goes to 3 is 2. What is f of 2? Okay, this is not a limit question. Take a look at the graph. F of 2 is the y value that's defined for this function. Not necessarily the limit as x approaches 2, but where's the closed circle at x equals 2? At x equals 2, the closed circle's right here at a y value of 2. Notice how when I do the next part, those two things may not necessarily match, because as x approaches 2 from the left and from the right, the limit exists, but they're getting closer and closer. These values are getting closer and closer and closer to 1, not 2. So what does that mean again? It just means that the graph is discontinuous at x equals 2. Okay, if those two things don't match. Okay, notice how we have a one-sided limit here. Now it says x approaches 4 from the left. The reason why is because you actually can't approach 4 from the right. We don't even have a graph out here. But as x approaches 4 from the left, I'm getting closer and closer and closer to 1. And finally, the last one is 1 from the left. Now, the limit as x went to 1 did not exist. But if I just approach 1 from the left-hand side, I'm getting closer and closer and closer to 0. I hope that makes sense to you looking at this graph here. We'll walk through one more together, the one at the bottom here. And then once we're done with that, you guys will take a look at the last page. Okay. All right, so this graph right here, it's a different function. What's the limit as x goes to 0 of this function right here? Do the left and right hand limits match as we get close to 0? Yeah, from the left, from the right, we're getting closer and closer and closer to 0. The y value there is also 0. All right, let's go actually just across the way here. Limit as x goes to 1. From the left side and from the right side, am I getting closer to the same value? And nope, does not exist. Is it working for 2 as I approach 2 from the left and I approach 2 from the right? Yeah, coming in from the left and right hand side of 2, I'm getting closer and closer and closer to 1. But when I say what's f of 2 is 2. It's where the closed circle is. That's the function value at 2. It doesn't have to match the limit. What about as I approach -1 from the right? Kind of have to approach from the right. We don't have anything on the left-hand side of -1. But as I approach -1 from the right, we're getting close to 1. And finally, limit as x goes to 1 from the left. So as I go to 1 from the left, we're getting closer and closer and closer to 2. Okay. So that's it really as far as the graphs go. I hope that helps you to make some sense of the last page. Even though there are some slightly new things on the last page, I think you can do it.